Have you ever heard of this idea? You can never truly die, because every time you face a fatal danger, the universe splits, and your consciousness always remains in the branch where you survive? This is called quantum immortality. It sounds both insane and deeply unsettling, but is it actually credible? Let's strip away the dramatic language and break down this thought experiment step by step, starting from the basic facts of quantum mechanics. It all begins with an experiment that has puzzled physicists for nearly a century. Fire a beam of light, or even single photons, at a barrier with two slits, and place a screen behind it. Intuitively, you'd expect the photons to behave like tiny bullets, passing through one slit or the other, and forming two bright lines on the screen. But that's not what happens. Instead, you get an interference pattern, alternating bright and dark fringes. This shows that light behaves like a wave, passing through both slits at the same time and interfering with itself. It gets even stranger. If you place a detector at the slits to observe which path the photon takes, the interference pattern disappears, replaced by two simple bands. In other words, the act of measurement changes the system's evolution. But here's a crucial clarification. This is not because the photon has consciousness or is afraid of being watched. The real mechanism is physical interaction. The detector inevitably interacts with the photon, for example, by scattering another photon into the measuring device. This interaction destroys the coherence between the two possible paths, a process known as decoherence in quantum mechanics. Once path information is recorded, interference disappears. At its core, measurement is a specific kind of physical coupling, not the gaze of a conscious observer. Now, let's scale this microscopic strangeness up to the macroscopic world. Erwin Schrödinger proposed a famous thought experiment, a cat in a sealed box, along with a vial of poison and a radioactive atom. Within 1 hour, the atom has a 50% chance of decaying. If it decays, it triggers the release of poison, killing the cat. According to the linear evolution of quantum mechanics, the atom exists in a superposition of decayed and not decayed. Therefore, the cat should also be in a superposition of dead and alive, until we open the box and observe it. This leads to the famous measurement problem. Why do we never observe a cat that is both dead and alive? When we open the box, we always see a definite outcome. There are two major interpretations. The first is the Copenhagen interpretation, proposed by Niels Bohr and Werner Heisenberg. It states that measurement causes the wave function to collapse, randomly selecting one definite outcome. The cat is either dead or alive. However, this interpretation never clearly defines what counts as a measurement. Is a macroscopic detector enough? Does human consciousness play a role? The second is the many worlds interpretation, proposed by Hugh Everett in 1957. In this view, there is no collapse at all. When you open the box, the universe splits into two branches. In one branch, the cat is dead. In the other, the cat is alive. Both branches are equally real, and the observer simply finds themselves in one of them. You see a dead cat in your branch, while another version of you sees a living cat in a different branch, and the two of you can never communicate again. In the many worlds interpretation, every quantum event leads to branching. After the split, each branch contains a version of you with a continuous memory of your entire life up to that point. There is no hierarchy between these versions, and none can perceive the others. If you die in one branch, that version of you is permanently gone. In another branch, however, a version of you continues to live. But this does not mean that a soul jumps from one branch to another. That surviving you is not a continuation that migrated from the dead version. It is an independent copy that has always existed along that path. This is where the idea of quantum immortality comes in. From your own subjective perspective, you would never experience your own death, because in any branch where you die, your consciousness simply ends. Only in the branches where you survive do you continue to have experiences. But this does not imply the existence of an immortal soul or consciousness hopping between universes. It's essentially a tautology. You can only experience the world lines in which you remain alive. Physicists strongly disagree on this idea. Supporters, such as Max Tegmark, argue that it follows logically from the many worlds interpretation. Critics, like Andreas Albrecht from Stanford, point out that it relies on a vague definition of the self. Even if the version of you in branch B shares your genes and memories, it is still, strictly speaking, a different person. You cannot claim that you never die, because the you in branch B is not the same individual as the one who died in branch A. More importantly, quantum immortality cannot be experimentally tested. You cannot ask a dead person about their experience, nor can you prove that you are in a survival branch. It remains a mathematically consistent but empirically unsupported thought experiment. This is different from the broader question of parallel universes, which might leave observable traces in cosmology. In fact, the idea of parallel universes also arises in cosmology through inflationary theory. According to cosmic inflation, the early universe expanded exponentially in a very short time. Different regions may have stopped inflating at different moments, forming countless bubble universes. Each bubble could have different physical constants, and they are causally isolated from one another. If our bubble universe ever collided with another, it might leave detectable imprints in the cosmic microwave background. Now, returning to the many worlds interpretation, it is mathematically elegant, avoids the need for wave function collapse, and removes the mysterious special role of the observer. But it comes at a cost, an infinite number of unobservable branching universes. In that sense, it is as much a philosophical choice as a physical theory. As for the psychological impact of quantum immortality, for those who carry regret or have suffered loss, the many worlds interpretation offers a strange kind of comfort. In some branch, you didn't make that mistake. In some branch, you didn't lose that person. But remember, this is only a logical possibility, not a supernatural reassurance. The purpose of science is not to create fear or false hope, but to help us understand the universe more clearly, including its uncertainties and the limits of our knowledge. Finally, let's return to Schrödinger's cat. After watching this video, you did not split into another version of yourself who didn't finish watching it. Because everything you experience at the macroscopic level already involves countless particles undergoing decoherence. The quantum branches have already separated at a microscopic level, and they will never interfere again. You exist in this universe, in this moment. You are real. As for so-called quantum immortality, it is merely a logical consequence. You can only ever experience the world lines in which you remain alive. It is not an immortal soul, nor consciousness jumping between universes. It is more like a mirror, reflecting how unclear our understanding of self and death really is. And perhaps, stranger than any parallel universe, is ourselves.